Ladies and gentlemen, good morning. My name is Alexio Picco and I'm the Managing Director of the Circle Group, and I welcome you to the Connecting EU Insights 2021 Spring Edition. We are in our third day of operation, let's say, and this morning we had already the first event dedicated to innovation in the rail sector, specifically about optimization and digital twinning in shunting operations. And now we move again to the sea, to the ports, and a bit also on logistics. And we have a very nice event on automation and innovation for short sea shipping, strictly also linked to an EU-funded project called Moses. We have a very high-level, top-level experts today. And I will immediately give the floor to Professor Venticos, that will be the Master of Ceremony. Let me just say a few words about him and introduce him. Professor Venticos is an Associate Professor in the Laboratory for Maritime Transport at the School of Naval Architecture and Marine Engineering of the National Technical University of Athens in Greece. He also the head of the Maritime Risk Group Research Unit. His expertise includes work in the fields of maritime safety and risk analysis, resilience engineering, human factors, maritime sustainability, environmental risk assessment. During his presence at the National Technical University in Athens, he has participated in and coordinated EU major funded projects, research projects, implementing innovative approaches, ensuring maritime safety and efficiency, and covering technical, human-related, and environmental aspects. He has published significant parts of his work in peer-reviewed journals and has given over 110 presentations and lectures at various international scientific conferences and symposia with topics relevant to his expertise. So it is really my pleasure to give to Professor Venticos the floor to be the Master of Ceremony and to manage as a moderator this very nice event. And I thank you for your participation. I remind you to stay online also this afternoon for the next interview we have at 2 o'clock with the head of port process solution in the port of Vampur, Fantian Zetsusongdoma. And thanks a lot. And Professor Venticos, the floor is yours.
Thank you, Alexio. Thank you for the introduction. Hopefully you can see me and hear me now. So I would also like to welcome all to this session. The session is entitled Shaping the Future of European Short Sea Shipping, Autonomous and Automated Technologies. And at this point, I would like to thank on behalf of all the panelists and of the Moses Project, the Circle Group for the invitation on this very interesting event. So we have a very nice session scheduled in front of us. We will start with a talk from the regulatory point of view from Sifis Papageorgiou from EMSA. The title is Automation in Short Sea Shipping from a Safety Perspective. Then we will go a little bit to the industry side, to the Port of Valencia with Mercedes de Juan Muñeiro on potential of short sea shipping in the Mediterranean basin. And as Alexio said, then we will focus on three major EC-funded project. We will start with AutoShip with Ornalf, Jan Rodseth from Sintef Ocean. AutoShip on demonstrating autonomous ships in Europe. We will continue with Aegis with Odd Eric Merkit from Sintef Ocean again. Aegis, the next generation short sea shipping logistics. And we will conclude this very interesting session with myself representing Moses. And the presentation, our talk is entitled Creating Opportunities for Short Sea Shipping and Small Ports Within the EU Container Supply Chain Moses Innovation. So as you can see, we try to draft an interesting agenda on this topic, so covering the same topic from various viewpoints and standpoints. So we will begin with a presentation by Sifis Papageorgiou from EMSA. And let me just introduce a little bit Sifis to all of you. Sifis, after graduating from our school, from the National Technical University of Athens back in 2008, passed almost 2 years in Norway as an approval engineer at the Norwegian Classification Society, DNV, before moving to Lisbon and EMSA about 10 years ago in 2010. As part of the ship safety unit, CIFIS has been involved in various regulatory issues such as damage stability and fire safety of passenger ships. And the last 3.5 years, he has been closely monitoring the mass file for EMSA, Maritime Autonomous Surface Ship file for EMSA. His work involves participating at IMO meetings on behalf of the Commission, following research projects, and as of 2020, he is also the coordinator of the mass task force at EMSA. So, CIFIS, you can share your presentation. The floor is yours. You have 15 minutes. We are all very excited to hear what you will present us. Just please turn on your camera if you like. Thank you very much.
Okay. Thank you very much, Professor Vendikos, for the very nice, very kind words. Indeed, this has been a brief overview of. Sorry, I'm not sure.
You should go in full screen. Okay,
okay,
now
there
it's
it is.
perfect.
There it is.
Thank you. Perfect.
Thank you very much. So thank you very much again for the introduction and for the opportunity to be part of this very, very interesting event today. I think I'm highly honored to be among this incredible experts in the field. And from my side, I will also give EMSA's perspective, and in particular with some focus on regulatory aspects of MASS. So with that, I'll go right into the presentation. So I'll start by asking a simple, let's say, question: why do we want, or why do we head towards autonomy or increased automation? I don't know if any of you will recognize this document. It is taken from an IMO document. Possibly a good colleague from the DMA will recognize it. In any case, this document, which says that there is growing interest in various applications of automation, is a document from 1964. Just as a reference, yeah, this is the year, the last time that the Olympic Games were held in Tokyo. So it's been quite some time that we are talking about automation, or that automation is around in shipping. Anyway, what I'm trying to say with this is that automation, of course, is not new in shipping, but obviously technology, and in particular computing power, has had a maybe trillion-fold increase, and of course this has brought a huge change in what is feasible and what is not. In any case, and however we were talking about automation already back in the 60s, I think that in the maritime industry, since then, and of course before that, when regulating, I think we have always been thinking that there is a human operator, or well, the master practically physically present on board, on the bridge, and I think this is really worth remembering when we will talk about regulatory barriers, because this thinking, this mentality is deeply engraved, let's say, in the whole framework. So why, still I haven't answered the question, why do we strive for autonomy or let's say increased automation? I would argue that the short answer to this is to improve, first of all, safety and sustainability as well. And of course, there are promises of financial benefits through adoption of automation. Personally, I will not go too much into this discussion, and also, for example, a lot has been said on the potential benefit of removing the human element, and this has also been discussed a lot in various forums that talk about MASS. I have to admit that I believe that it is possible to automate ship functions in a safe manner and have benefits for all three aspects that I mentioned here. But one of the issues that we have, I think, as an industry is that we have not proven this yet. And this is why for even the let's say most advanced and well-funded concepts and projects that we have seen, there is of course a significant period of trials that has been that is foreseen. So again, are the various concepts, for example, safe enough, and how do we prove it? I would say that the short answer is, well, we don't know that yet. Of course, we can predict and we can foresee that there are benefits, but we simply don't know. But in any case, a lot of really good people, and some of them are here today, and stakeholders, administrations are putting a lot of effort on this. So I think we will make steps into this direction in the near future. And just as a point, and I will come back to the short sea shipping case, it is also clear that for various reasons, for short sea shipping, it seems to be the most attractive case for concepts of increased automation. And with that in mind, I will go now into what we at EMSA have been working on these last 3 years in relation to MAS. And first of all, I would like to mention the SafeMAS study. And this was a study, rather a desk study, I would say, on risks and regulatory issues of some specific cases of MAS. And whoever is interested can download this study on EMSA's website. But of course, we have a task force working on autonomous ships, on MAS, and I think we have a lot of good expertise, and the people are working on different issues. For example, we are working on appropriate digital services for MAS. There is a lot of work going on in EMSA in providing digital services, and what the good colleagues are working on is how to introduce MAS in such environments. Also, there is a lot of work that is especially picking up now on remote control center competencies and what kind of competencies is needed. There is a lot of expertise in EMSA, in the STCW convention in relation to, let's say, the training of seafarers. We are also currently working on cybersecurity issues. And of course, we are heavily involved in regulatory processes, both in a European and an IMO level, so that there is a lot of activity going on. In any case, today I would like to focus a bit more on the RBAT study, which is a study conducted by, it's ongoing, and it is being conducted by DNV. And the study is practically, RBAT stands for risk-based assessment tool. And by tool, I mean practically a software. So automation for the automation, which is supposed to risk assess whether the introduction of automation or autonomy is as safe, or at least as safe as conventional shipping. The study itself is separated in 3 parts. As you can see here, we are now finalizing the first part, which is developing the framework on which the tool will be based on. And in the next 2 years, so we foresee that the study will be concluded in 2023. We will work on the tool itself in testing, but we still have a long way to go until that. How is the RBAT connected to the current regulatory framework? What we had in mind when we were planning the tool, the study, was mainly the EU operational guidelines on MAS trials. and these guidelines were drafted for the EU, but they also introduce some basic instructions on the risk assessment. And for the risk assessment of such new concepts, there is it is recommended to have two approval phases. One preliminary phase where typically the concept or the CONOPS is being submitted to the approval authority, and then after that is being discussed or approved, then the second phase is the detailed design for the full approval of the concept. So what we were aiming at with the RBAT is this first is to standardize and facilitate this first part of the approval. And what we had in mind was to have a sort of non-binary outcome. And by that, I mean that the tool should not just say, yes, this is approved, or no, this is not approved based on some specific data, some input data, but that the tool guides both, let's say, applicants, so concept and system designers, but also the administration or the approval authority by providing a tool that is transparent, that is coherent and analytical in the way it presents, let's say, the work that has been done. And if you are into risk analysis in general, you know that we normally talk about really heavy documentation or Excel files that have hundreds of rows. And what we want to do here, of course, is to standardize this process and facilitate it by also making sure that nothing is forgotten and that the risks are taken into account. I will also give you a very brief overview of what we are discussing. As I said, we are still in the phase of creating the framework and the tool in general. So this is what we are currently discussing with DNV, and typically the tool is designed in a hierarchical manner where the objectives and functions are introduced. But what will be introduced by the applicant is information on what is automated and how it is automated. And the tool itself should be able to give, let's say, answers on how this system can fail, so the various failure modes, but also on whether this, let's say, what has been planned is safe enough. So some sort of comparison to the current safety level. As I promised, I'm going back now into the short sea shipping case, and I will try to merge these two thoughts. So I'll go a bit out of the automation world, and I will say that the main priority areas for the European Commission on short sea shipping are these three that are listed here. Basically, we're aiming at administrative simplification, supporting the industry in picking up technologies on sustainability, and also integration, let's say, of short sea shipping in full logistic chains. And the question is here, can MAS be the answer to these efforts? If one would judge from the existing or the projects that have been developed so far, one could argue that this seems to be the case. That at least for these, let's say, issues, MAS can provide answers. So therefore, I think that the question could become more, is there a business case for this? And I'm pretty sure that Ernulf would also touch on this, so I will not go further. And I think Autoship and all the projects today are doing a great job in diving into this subject. And to conclude, I would like to bring up some final remarks. So from our side, EMSA, as you saw, we have a lot of different items that we are currently working on, and we do foresee that we will continue working on these items, supporting EU member states and the European Commission. As I also said, the RBUD project, we do hope and we have the ambition to standardize these early stages of the approval processes on mass concepts, thereby facilitating these significantly. I don't think this is really the third one. I don't really think it's a prediction. It's already true. So what we see is that short sea shipping is practically the first field of application of advanced automation. So again, don't quote me on what advanced automation is. What I have in mind, at least, is concepts where there might be unmanned ships with a remote control center. And finally, to conclude, just to say that in any case, regarding the reasons that we do automation, I think it is always good to remember that automation is a means to an end, is a means to achieve safer and more sustainable ships, and it's not the end in itself. So, and with that, I will conclude my presentation. Thank you very much.
Thank you, Sifis. Thank you very much for your interesting presentation. Thank you for explaining us the priorities of the Commission and how you see things. Okay, I can see through the, just to make it a little bit more interactive, we can, put in front a couple of questions and then we will proceed with the next presentation. I can see a question regarding risk assessment for this kind of, ships. Can you elaborate a little bit on that? You have already explained through AirBat some things, but just, a couple of words. On top of that, we see that I see at the Q&A something that refers to inland shipping, that there are already some, projects for centers, remote control centers for barges. If you can also elaborate a little bit on that as well. Thank you.
Okay, thank you very much. Regarding the risk assessment, first of all, I would say that since we don't have a regulatory framework in place on automation, this is typically resolved by following alternative means, and these alternative means always or almost always introduce a risk assessment. So I think that as long as we do not have a regulatory framework, and I do think that it will be very difficult to have a very specific and prescriptive regulatory framework on mass, we will be looking at risk assessments that will be taking place, yes. So this is at least, this is what I have seen in talking to people that are involved in the projects that have gone a bit, that are a bit more advanced, like the Yara Birkeland, or now the ASCO or the milliampere. So for several of these projects, this is what we have heard, at least, and this is not from us being directly involved as EMSA. Regarding the inland waterways, I can say that indeed, yes, I'm generally not an expert on inland waterways, but of course, through mainly the Autoship project, I have heard a bit more about, let's say, what is going on, and I have participated in some conferences and have met some people that are working on this. However, and there is a lot of good progress done in inland waterways, so this is correct, and this is acknowledged. Still, I would argue that, for example, the level of advance that we have seen already in Yara Birkeland in particular, it is not yet there in inland waterways. Maybe the inland waterways will overtake, let's say, short sea shipping, but this is difficult to say at the moment.
Thank you, Sifis. Thank you very much. I see now that we have received more questions on the Q&A. Sifis, if you are polite enough, just go through them and try to reply to them. I know that Ornalf from Autoship has also replied the one about why selecting short sea shipping as a potential candidate for mass and autonomy. Just if you may just go through and answer the questions on your part. Thank you very much, Sifis.
Okay.
Thank you very much for the interesting presentation. And we will proceed with the next presentation. The next presentation comes from Mercedes de Juan Muñoyero. I hope, Mercedes, that I am pronouncing your name correctly. She comes from Valencia Port Foundation, and Valencia Port Foundation is actually a partner at the Moses project. You will be talking about the potential of short sea shipping in the Mediterranean basin. And just a very brief introduction of Mercedes. She has been working in the maritime sector from 2000 in positions related to global marine electronic solutions and connectivity, including satellite communications, shipbuilding, and fleet maintenance. She holds a master's degree in naval architecture and marine engineering and an MBA from the Polytechnic University of Madrid. She's also an expert in maritime shipping sector and IMO's work in addressing emissions from ships. So, Mercedes, the floor is yours for the next 15 minutes. Please go ahead and share your presentation. Thank you very much.
Thank you very much, Professor Venticos. I would like to thank Alexio and you for inviting us to take place of this event. And also I would like to thank Elena for her support at any time. My presentation is mainly focused on providing several market insights and several guidelines for implementing or for promoting the use of the short shipping services. Fundación Valencia Port is a research center. It's a research center associated to the Port of Valencia that has been promoted by the Port Authority with the aim of generating value for the port community, for the whole port community. In this sense, we are not working only for the Port Authority, but also for the whole port community, for any company that has any activity related to the port operations, shipping agents, freight forwarders, terminalists, etc., etc. We work in 3 separate areas, promoting the innovation or keeping update the port community in the most innovative technologies. The second one is for maintaining the competitiveness of the port is crucial. The training, keeping the port workers and the port community update. And finally, the knowledge that we gathered mainly through our participation in research project is capitalized through consultancy services. Well, I'm going to provide an insight on several figures about the Port of Valencia. The Port of Valencia is one of the biggest ports in the Mediterranean, the biggest European port in the Mediterranean. In 2020, we have slightly affected by the pandemic. And finally, we finished the year with similar numbers to the previous one. We have moved more than 80 million of tons, close to 5.5 million of TEUs, and more than 500,000 vehicles. The passengers is obviously the passenger traffic has strongly affected, which is normal due to the current situation. Import and export represent close of 50% of the transport movements, or the movements of goods in the port. Regarding the position of the port in the short shipping, Spain is the third country in Europe which much more would move in short shipping services, and all these shipping services are gathered by 3 ports in Spain. The ports of Barcelona, Valencia, and Algeciras accounts for more or less 7% of the goods moved in short shipping services. Then we consider that we are a successful case of implementation of the short shipping services, and this presentation aims to provide the market insights and several guidelines for implementing it, as I mentioned before. The evolution of the traffics in terms of total traffics and containers has been constantly growing. Just only the last year has been affected by the pandemic, as I mentioned before. The main part of all traffics, is not the main part, but the most important area that all traffics originates or is destinated for is in the Mediterranean and Black Sea, which accounts for nearly 30%. When we are talking about the advantages of the short shipping services, everybody has in mind the environmental impact, but there are others that are also relevant. Depending on the distance covered, the short shipping services can reach important savings in terms of time and money, as we will see later. It contributes as the service contributes to reduce the logistic cost. This means that increase the competitiveness of the final client, because the prices, the final price that reacts to the cost, the final customer, is influenced by the logistic cost. It's obviously that has a less environmental impact, but also the short shipping services deal with the main road transport constraints. The time the driver is stay at the vessel is considering a resting time, which is very important from the point of view of the legislation. Contributes to increase the quality of the life of the driver. It's quite obvious that the driver is resting at his cabin and has full of services as cafeterias, restaurants, and so on. What is quite different of being driving alone in a road and sleeping in the truck. The short shipping services are less influenced by the fuel prices, the increase of the volatility of the fuel prices, is less dependent on the land transport infrastructures, and also contribute to avoid the typical problems caused by the road transport. Bottlenecks, traffic congestions, traffic restrictions. Sometimes the trucks are not allowed to be or in several or to drive during the weekends or in several areas for particular restrictions. Contributes to reduce the penalties and the insecurity or the unsafe. In general, the drivers suffers. This is an exercise for providing an overview of the savings, mainly of the savings, when you compare the short shipping service by the same distance covered by truck. The first example is a good moving from Madrid to Turin. And you can see here the cost, the different costs which is you have an important saving in the cost. In this case, as the route is very short, the impact in the time is not so big, but also it's necessary to consider the cost of the externalities. When we are talking about the cost of the externalities, we are talking about congestions, accidents, pollution, the effect of the climate change, the noise produced by trucks, maintenance of infrastructures, maintenance of the vehicle, etc., etc. Then, as you can see, here has also an important impact. The second is moving goods from Sevilla to Civitavecchia or to Rome. Then, as you can see, the impact in the cost is very important, close to 50%, sorry, 25%. The saving in time is not so big because it is the impact in this case is bigger when the distance is bigger as well. But also the impact in the externalities is close to 50%. I'm going to provide an insight of what the source shipping services represent in Europe and in particular in the Mediterranean. The source shipping services account for 60% of the total movement of goods in Europe. As you can see here, two countries, Italy and the Netherlands, accounts for 30% of the services, the movements of goods in Europe, followed by Spain that accounts for 12%, and Germany that accounts for more than the 9%. Regarding the transport or the goods transport in the source shipping services, in the Mediterranean, the most important are the liquid goods, which accounts for more than 40%. And in general terms, bulks, liquid, and rice accounts for 60%. In the case of the containers and ro-ro units, accounts for more than 30%, which is an important part of the traffic as well. 40 ports in Europe accounts for 20% of the total traffic. If you look at these ports, the hub ports, the main hub ports in Europe, each of them, Rotterdam, Antwerp, Amsterdam, Valencia, Algeciras, Barcelona, etc., etc. The impact of the source shipping services is lower than the deep sea shipping. But when you look at the small ports, the impact of the source shipping services is higher. This part is focused on how to implement the source shipping services. The most important is having the view of the client, of the customer, of this kind of services. What is looking or what we offer to the client? What we offer is increased efficiency. And what is the definition of the efficiency? It's very simple: more and better for less money. This is what we are offering. And for offering this, we put the focus in increase the flexibility, fastly adapted to the market situation, regulatory situation, and any potential change that occurs in the market. Better infrastructures, modern infrastructures and well-connected, and lower direct and indirect costs. Then this concept is could be summarized as very good infrastructures, well-connected, increase the quality of the services, and a very good organization. We enter in depth what we are offering. We are offering connect 51% of the Spanish GDP, with a huge market of 274 million of customers. And we connect this in an easy way with the position of the port and the connections the port that has with other main ports in Europe, combined with excellent road and rail connections. Regarding the quality, we overseen the quality of the services provided, not just by the port, but also by the terminals and the shipping companies. This example is focused on the ferries because it's easy to see, but it's important. Reduce the environmental impact. The projects that you will see later address this issue. Accelerate the loading and unloading times. As you see here, well, the size of the entries to the vessel is very small, then the speed could not be very fast. This accelerate or reduce the time for loading and unloading the vessel, and reduce the damage. This is an example of assistant using for lashing the trucks and the cars to the vessel, and usually produce several damage in the tires of the vehicles. The second one is introduce the simplicity in the management of the bookings and the port access procedures. We are moving to a system in which just with the booking pass or just with the cargo declaration and so on, you are able to enter at the port and reach the terminal with to stop at any place. This is one of the things that we offer, and a system, a complete system online, fully connected with all the actors, the main actors in the port, for facilitating and decreasing the administrative burdens, which is really very important for increasing the productivity of the port, the productivity of the terminals, and the productivity of the short shipping services. What a port authority can do for promoting the short shipping services. First of all, facilitating preferential berthing and unloading just at the arrival. Enable fast and safe movements in the quayside. Promoting good inland connections, as I mentioned before, and reducing the port taxes. This is crucial. The Port Authority of Valencia has a mechanism for reducing the taxes in function of the number of cars, but also in function of the environmental impact of the services provided. It is the Port Authority offer a discount in the port taxes of 50% with the condition of investing 35% of this discount in reducing the environmental impact. And this environmental impact is measured in terms of CO2 reduction or sulfur reduction and NOx reduction and so on. But supported by measures, not supported by a certification that someone provides or something like this. It's also very important to coordinate the relations with other administration and ports for facilitating all the service that we provide to the client, to the customers, to our customers, control the quality of the services and facilitating the business. We are going to enter in depth in these 3 points, in 3 cases of how to promote in an easy way the relations with other administration and ports, increase the quality, and so on. For doing this, we believe, as I mentioned at the beginning, that the training, the port community is crucial for providing better services and for increase the cooperation and the fluent cooperation with the internal port community, with other ports and other administrations, etc., etc. We have a very strong cooperation with the Port Training Institute. We give several courses in which attend the main ports in the Mediterranean, in the North Africa countries. We have permanent programs for training people in the Mediterranean. The JetMed project is a good example for promoting the young employment in ports in the Mediterranean. And also it's very important the work in the field that we are doing in the framework of the MedPorts Association. It's also for facilitating the business among other actions. We provide several market research on source shipping. In particular, Fundación Valencia Port manages Lineport. Lineport is a database of all the source shipping services that there are in Spain. In this database, born in 2004 as a tool for supporting the implementation of the European policies in terms of source shipping services. Initially, this tool tries to fill the gap regarding the data, the statistics about this kind of traffic and so on. But has evolutioned for providing market information to mainly to the shipping companies. We provide information about how many shipping companies are operating the traffics, the source shipping services, how many trips per week are making every company, how to connect with information about to connect how Spanish port with other ports in the world, in Europe and in the rest of the world, etc., etc. And we also provide information about the global economic environment at every time. This is a report that we made in collaboration with the University of Valencia that gives an insight in the global economic situation. The focus on the opportunities that we have and the potential risks associated, mainly associated to the economical situation. And we have developed also the first containerized freight index in the Mediterranean. With all this information, the shipping companies, because is the most important client the port has, if the vessel doesn't arrive at the port, the rest of the logistics check is stopped or not make sense. Then, with this information, we provide relevant information for selecting the Port of Valencia as a key partner, for providing opportunities of business, opportunities for the companies that are interested in import or export. Several times we have made specific studies for instance, the wine sector, looking for the opportunities for export their products to the rest of the Europe. As we mentioned before, we are offering a market of 207 million of customers, which is very important. And we have also collaborated with relevant shipping companies in making feasible analysis for implementing new services, new lines, or also implementing measures for reducing the environmental impact. such as new fuel services. And this is all from my side.
Thank you very much, Mercedes. It was a self-comprehensive, very comprehensive presentation. You presented very nicely the situation about South Sea shipping, and especially within the Mediterranean basin. I would say there is a question for you and for Spanish authorities regarding autonomous vessels. If you can type your answer on the chat, it would be fine, Mercedes. Thank you very much. So we can close this question as well. There's another question about connectivity, but I'm certain that the next speaker, Ornalf, from exactly from the project of Autoship, will reply and will cover this issue as well. So before passing the floor to Ornalf, let me just introduce him very briefly. Mr. Ornalf Jan Rodseth, I'm sorry if I'm doing something about the pronunciation, Ornalf, has an MSc in cybernetics and electronic engineering from 1983. He's a well-known researcher for more than 25 years in the maritime information and communication technologies. In the last 10 years, he has worked mainly with autonomous ship technology and maritime digitalization. He is a senior scientist at SINTEF Ocean, Norway, and is a general manager in Norwegian Forum for Autonomous Ships. He is a member of ISO TC8 and IEC TC80, and regularly meets at IMO as observer for exactly ISO. Ornalf, the floor is yours. You can share your presentation. And for the next 15 minutes, we are very eager to hear what you have for us. Thank you very much.
Thank you, Nikos. Let's see if we can make this work. There. It's the wrong presentation.
We are up and running, Ornalf.
Yes, but I took. Yeah, okay. First, I should say that for those who don't know SINTEF Ocean, we are now a part of the SINTEF group, non-profit, independent research organization, mainly Norway, about 2,000 employees, 350 of us in SINTEF Ocean, which also includes what used to be called the Marine Tech, for those who have some historical links to us. So first, I thought I should say something about why autonomous ships. And also, as Sifis said, this is more or less something that is happening. If you look at the number of crews on the ships declining from the sailing days to today, with less than 20 people on the big ships, it's really a function of automation all the way. And autonomy is, in a sense, the natural continuation of this trend. And normally what we want to do is to automate where it's dull, dirty, or dangerous. And you could say that the sailing for long distances at slow speed could be quite dull. It can be dirty, particularly with some types of cargo handling, and it can also be dangerous. Most of the occupational hazards is on your own ship, but accidents happen, as we recently saw in the North Sea with Emslift incident. As has also been mentioned, the issue of moving cargo from road to waterways is also very important, particularly for inland shipping, which was mentioned, and also for short sea. And there is also issues related to various types of disturbances from the truck, including particulate matter, dust from asphalt and so on, noise, and a lot of other things. So basically, it's a good argument for moving more cargo to sea. And also, it's important to recognize that shipping is basically the lifeblood of the world. It's about 90% of international trade is by ship, and this includes food, raw materials, oil, and a lot of essential goods. And it's also a big part of European transport. About 90%, I think, of liquid fuel to EU is transported by ship. And it's also an extremely sustainable type of transport with a significant lower greenhouse gas impact than other modes, most other modes. But we still need to meet the climate challenges and find a way to decarbonize shipping, which is a major problem, which we are looking at in other projects. Cost of energy, for instance, will be up to 6 times higher than for traditional fuel oil. Volume of energy is also a big problem. It takes a lot of space to store some of these new fuels. This is one of the reasons why we look at autonomous ships, because they provide new opportunities. If you can remove the accommodation, you can make more space for cargo. Accommodation, particularly on small ships, use a lot of energy, and you can design ships totally different. And these are also some of the reasons why we are looking at short sea, because short sea ships tend to be quite small. And both crew cost and the size of accommodation, the relative size of accommodation is quite big in relationship to the cargo. And this is also basically the background for the projects that are running today, ASCO and the European, which are the 2 commercial projects. That they are introducing new types of transport system, replacing trucks in both cases. And inland waterways was also mentioned as a possibility of introducing smaller and more flexible transport facilities in the maritime trade. But still, in most cases, this will be overseen in some form by a shore control center. We are not necessarily looking at fully autonomous ships. So why autoship? As has been mentioned, it's not trivial to make an unmanned ship. You have to have new types of sensor systems, new types of navigation and maneuvering decisions. There is a big safety question, at least, which requires quite extensive risk assessments and so on. You have to solve the problem of maintaining the ship when you don't have crew on board. You cannot use heavy fuel oil. You have to go to other types of fuel and so on and so forth. There will be some costs associated with the shore control, repairs and whatever. You need more and automated shore infrastructure. And it will be a long time until international legislation is in place. And the last point is also one of the reasons why we are looking at short sea shipping first, because it involves only 1 or 2 or 3 governments that have to give their permit to operate with exceptions from national law. If you have to wait for IMO, it will take a very long time. So basically, there's a lot of risks and uncertainties in this area. And there are developments, and we have already several commercial projects underway, but it's going not very fast. And I claim that one of the reasons why this is the case is that the investment, there's too much risk associated with the investment. And this is also one of the reasons why we are seeing these smaller ships. It's a much lower investment buying this ASCO ship than, for instance, trying to automate a big container vessel. And this is also why we launched the Autoship project, to try to show that these risks are much smaller than most people think. So one of the parts of Autoship is to develop what we call 7 key enabling technologies up to at least the TRL7, and show that this really works and that it can be approved for use in the selected use cases. I won't go into detail. You can look at the web pages, and there is a brief overview here, but it's basically what you could call an artificial captain with the maneuvering, remote control, and all this stuff, and also an artificial chief engineer taking care of the technical operation and the maintenance management. So this is one important part in Autoship. which is currently underway, and we are putting quite a lot of resources into this. But the other part, which is, I would say, essential in the project, is to demonstrate this new technology and also the approval of the technology for use in real cases, in two use cases. One of them is, in fact, an inland waterways case together with Blue Line Logistics in Belgium, operating near the Schelde and in the small canals there. The other case is a short sea shipping route. It's a fish feed carrier. In this case, it's today operating in Norway, but the ship will also take a trip to Denmark and address all the regulatory challenges that we have to solve to operate autonomously in Danish waters. This is a more typical short sea bulker, basically. The fish feed is what it carries, but it could be anything, basically. And the point, of course, in the project is to prove that the concept works by having all the technical systems tested, risk analysis and approval, having the concept of operation and all the regulatory hurdles for the operation in the proposed use cases, and getting the national approval for operations in Norway, Denmark, and Belgium in this case, and also doing the cost-benefit analysis, showing that this is, in fact, a viable way forward for creating new types of transport systems in short sea and inland shipping. So this is basically what we are doing in Autoship. It has a total budget of about 30 million euros. It's a quite high level of funding, and the reason for that is that we also include these real-life demonstrations, which are quite expensive. It will run until about the end 23. So we are around halfway now. And you can follow us on our web pages. And you can also find more information on the Norwegian Forum for Autonomous Ships and the National Network of Autonomous Ships web pages. So, thank you.
Superb, Arnulf. Thank you very much. Thank you for giving us a flavor of what you're doing at the Autoship project. I would say if you can go through the Q&A, there are a couple of interesting questions. So if you can reply to them so we can continue with the next presentation. Thank you very much, Arnulf.
Thank you.
The next presentation comes will come from Odd-Erik Morkrid, again from Sintef Ocean, and he will present the Aegis project. Let me just introduce very, very briefly Odd-Erik. He graduated from with an MSc on engineering cybernetics, vessel control and navigation from NTNU Trondheim back in 2008. He has worked as project engineer and project manager in marine cybernetics from 2008 to 2014 with hardware in the loop. These are very interesting terms. Testing of control systems in offshore and maritime industry. And also he has worked as project manager in DNVGL from 2014 to 2020. Again, both with hardware in the loop projects and innovation projects. Currently, he's working as senior project manager with autonomy logistics in the maritime segment as part of the Sintef Ocean and the group Maritime ICT and Cybernetics, where he's now he's currently coordinating Aegis, but also working with other projects like the Norwegian project SFI Autoship. Odd-Erik, the floor is yours for the next 15 minutes. We are very interested to see what you're doing at Aegis. Thank you very much.
Thank you for the nice introduction, Nikos, and thank you for having me. I will see if I am able to share the screen in the right way. Let me see here. Is this the correct view you see now?
Derek, I think we are looking your presentation with the notes. So now I think we are fine. Yeah.
Okay, good. It's a 50% chance to make it correct. Okay, so I guess the title for today I put next generation short sea shipping logistics, but we are also looking into inland waterways. So I just wanted to say that, but I will focus on the short sea in this presentation. First, the UN's Sustainable Development Goals, we are focusing on 4 of them: renewable energy, innovation and infrastructure, sustainable cities and communities, and finally climate action. And I will just say first briefly the background of the project, and then go into what I define as the next generation logistics system, and present our use cases, and then end with some more information of the project. So you all know about the EU ambitions, and you have all seen this picture. Actually, it's the same picture as Ernulf showed just recently. We want to move from road to sea, and with 30% by 2030 and 50% by 2050. So having that in mind, I'm heading over to what I like to call the logistical challenge, because what we have today is this simple picture. You can have a truck going from A to Z and back from C to A, and we are now trying to move to ships, and obviously they cannot go from A to Z. They can go from one terminal to another one. So we will have to look at hinterland as well here, and in the end we'll probably need trucks for the last mile automation. And the question then is, how can we make the part down here competitive with the trucks and road transport? And then we need advanced, efficient and green intermodal systems, which is what AEGIS stands for. So then the next generation sustainable waterborne logistics system, how will that look like, and what will we do? We will redesign the logistics system, meaning that we will develop a new user-centered logistics system based on autonomous components, some part of autonomy at least, with better services quality and lower impact on environment and society. And in that goes introducing more diverse sizes of ships, because we see that big container ships, they cannot compete in the short sea segment. If you look at covering small ports in, for example, fjords and canals, we introduce what we call mother-daughter solutions. That is when if you look at the container ship as a mother, you can have small autonomous vessels that serve as daughters for the mother. I will come back to that in one of the use cases. We'll need more flexible ship systems, meaning that you can maybe you need some kind of multi-purpose ship that can handle different types of cargo, or we need different types of cargo handling equipment. There must be more automation in the cargo handling, both on board the ships and also at the terminals. And one way of enabling more automation is to standardize the cargo units, and our main focus in AEGIS will be on containers, because they are easily connected to other transport modes as trucks and railway. One other important factor here is digital connectivity, and international ship traffic and local port logistics are hindered by the lack of digitalization and a lot of paperwork and different systems where we report. So we'll try to gather everything into one common way of communicating between the stakeholders and connect ship systems to, for example, terminal operator systems. Within digital connectivity goes also cybersecurity and the resilience of the communication. So then to the most interesting part, the use cases. I will spend most time on short sea shipping use case, but then we have two more on inland shipping and one where we look at the ports side of this logistics system. So use case, the short sea use case is based on a Norwegian case. And it's led by a North Sea container line who has container ships going from Rotterdam to the coast of Norway, visiting a lot of terminals all the way up to Tromsø, far north. And we will zoom in a bit to the Trondheim fjord. And the red line here is showing the fairway of this container ship. And today it goes into Orkanger, just inside the fjord here. But if we want to enable the short sea or the waterborne transport in the fjord, we will need to have smaller vessels visiting these small ports that are denoted with blue dots here. And these small ships could be like the upper one here has maybe 3 or 4 TEUs. The second one is maybe about 50 TEUs. We don't know yet. It's analysis we are doing to find out the potential there. Another thing is that these small vessels here, they will need to be autonomous and have automated cargo handling systems if this is going to be viable. The next use case is based on the canals and in the waterways in Belgium and Netherlands, and it's led by DFDS, who today is having a lot of trucks in the Rotterdam area. Especially, there's a lot of congestion, as you know, and 55% of the truck hours is in queuing or in congested areas. So there is a huge potential in moving this to barges and preferably ro-ro barges. And you have seen these pictures before today. This one is from Zulu Associates, the pallet barge, and it's the ro-ro ASCO barge down in the right corner. So we will come up with ro-ro barge concepts that can compete with trucks, and they will need to be fully autonomous cost-wise if this is going to work. Then the next case is called revitalizing regional ports and city center terminals, and we have Port of Aalborg and Port of Vordingborg, who are both partners in the project, and we will, in this case, increase efficiency to the value chain and increase competitiveness towards road transport in small and medium ports, and use these ports as test sites for the application of technical developments in Aegis. That goes for new terminal concepts. We have MacGregor and Cargotech in the team as well, and we're looking at and how we can optimize the terminal operations and from the ship to the terminal, and from the terminal out to the hinterland and the trucks, and especially for Port of Aalborg, look at how we can connect this to the railway as well. Then I wanted to include just one specific example on some of the work we are doing in Aegis these days. And this picture shows at the top here the Terminator operating system from Grid Connect, who is also a partner in the project. There is an illustration from MacGregor here showing robotic container handling system in a terminal with the ship here. And the last picture is showing a 3D mapping of the terminal area. And the idea here is if you can imagine a vessel calling a smaller port at night, when usually the small ports are closed, then an autonomous crane can discharge, let's say, 5 to 10 containers. There will be no need for a crane operator or port operators, and there will be no need for interaction with the terminal operators, and you can operate 24/7. If you have digitalized all the cargo equipment and the bollards and things that you need for the autonomous systems to act together, because the autonomous ship will need to know exactly where to dock, and the autonomous cranes will also need to know the exact locations at the terminal area where to put the containers and where to put it on the ship. So Grid Connect has done a lot of this in some Norwegian terminals where they have had some mobile mapping and using some drones, and so together with MacGregor and Cargotec, we are doing some very interesting work in this project. I also need to mention a couple of other things we do in the transition towards the next generation short sea shipping in the EU. We also have to include something about policies and regulations. And as Ernulf said in his presentation, we also do cost-benefit analysis in Aegis. So when it comes to policy support and measures, we just say a few words. We will investigate whether do existing legal requirements applicable to short sea shipping fit the policies that are calling for a transition from land-based to automated maritime transport logistics. And we also need to find what are the regulatory and policy hurdles that are encountered by stakeholders today. And then after that, propose some implementation measures for policy instruments. One example here could be the European Maritime Single Window Environment Regulation. Then to the cost-benefit analysis, they will be based on KPIs, and I will just mention the KPI groups we are looking at. We have the economics, which speaks for itself usually. We have the environmental KPIs, and goes for greenhouse gases, pollution, biodiversity, etc. And also the social KPIs on safety and security, employment and labor conditions, etc. All of these summed up should give us a sustainable maritime transport system. Then I would just like to finish off with showing you the partners and the funding for the project. And from Norway, we are SINTEF, Grid Connect, NCL, that is North Sea Container Line, and the Port of Trondheim. From Finland, we have MacGregor and Cargotec. From Denmark, I've already mentioned DFDS, Port of Aalborg and Port of Vordingborg. In addition, we have the universities, Aalborg University and the Technical University of Denmark. And the final partner is the German ISE, which stands for Institut für Strukturleichtbau und Energieeffizienz, if I'm pronouncing it correctly. Sorry, I clicked a bit fast there, but anyhow, more information of the project can be found on our webpage, or as Ernulf also said, on the NFAS and INAS pages. Thank you. That's it from my side, Nikos.
Thank you, Derek. Thank you for sharing all this information with us. I think that Aegis and Moses can have many synergies because I believe that we are looking at the same problem from different perspectives, and hopefully we will continue our cooperation towards this end. There is a question of Eric on the Q&A. Ornulf is replying right now, but if you would like also to give your perspective, it would be more than fine. Thank you very much for your presentation. And we will continue. We have left 10 minutes, so I will try to go very fast with the presentation from our side. Let me see how I will share my presentation. Share the presentation. Share. Hopefully, you can see our presentation as well.
Yes, Dr. Ventikos, yes.
Thank you, Elena. I will, as I said, we have like 8 minutes, so we will try to go very fast. The title is Creating Opportunities for Sources Shipping and Small Ports. Please note the small ports within the EU container supply chain, and we will discuss about some of the Moses innovations. Sources shipping in the EU, already the previous speakers covered that. There is an aim at transferring cargo from land-based transportation to more environmental friendly modes, and to increase the share of sources shipping in this effort and in the container supply chain, we need feeder routes to reach more destination ports and feeder vessels to be able to carry more or less cargo in a cost-efficient way. So what we are looking for solutions. Sources shipping to small ports with no cargo handling infrastructure could provide an alternative to land-based transshipment. We are searching for efficient solutions, green and safe solutions. So this potential is mostly untapped because existing feeders cannot be served by small ports, and there is a small or little incentive for carriers to choose maritime transport instead. Many times this happens over a road or rail modes. Now, the Moses, the project runs up to 2023, end of June. The title is Automated Vessels and Supply Chain Optimization for Sustainable Sources Shipping. You can see the budget of the project is around 8 million, and the consortium, it's a multidisciplinary consortium. We have partners from Greece, Cyprus, Italy, Circle, who is the organization that kindly invited us here, Astander from Spain and Valencia. We have partners from the Netherlands, from Denmark, and from Sweden. The aim of the Moses project is to enhance the sources shipping component of the European supply chain by addressing the vulnerabilities and strains related to the operation of large containers. So let's say it's like a twofold strategy here. About sources shipping feeder services, we want a logistic solutions for balancing demand and supply, and for the deep sea ports efficiency. We are looking for technological solutions for improving this kind of ports and the efficiencies of these ports, reduce, for example, berthing time, improve safety, and this kind of advantages. So what we are looking here and what we are looking in Moses, it's to create new pathways in the EU by integrating small ports with no infrastructure at all into the overall EU container supply chain. So, for example, we can have containers from large container terminals, as you can see on the picture on the left-hand side of this slide, to small ports through dedicated sources shipping feeders. You can see that in these small ports there is no infrastructure at all to deal with containers. Now, we have this a slide on with just one question: what are the key components of the next generation of short sea shipping in the EU? So any of the attendees who wants to to answer to that question, please use this QR code to do so. Thank you very much. Now, the concept of the Moses, very, very quickly, we have the mother vessel going into the big port. We have a swarm of autonomous tags that they are controlled by a remote control center at the port mainly, that they control the entrance and the maneuvering of this big mother vessel. And at the same side, we have an automur system that it cooperates with the autonomous tugboat swarm, comprising what we call the Moses autodock system. Then we have the Moses feeder vessel with a robotic container handling system mounted on board this feeder vessel. The feeder vessel then goes through the feeder line to a small port where it can self-unload the containers for the specific port. At the same time, there is, as we can understand, this or part of this trip of the feeder vessel can be done in an autonomous manner. So there is, let's say, a shore control station and for the feeder vessel. And there is also a Moses recharging station in the case in case that we have an electric feeder vessel. On top of that, we have a matchmaking platform, which, as we see, can support the logistics of the containers. So if we focus on the Moses innovations that they are, closer to short sea shipping, we are talking about an autonomous feeder. You can see here some very, let's say, basic points like enhanced maneuverability and position keeping capability, enabling the operation in unprotected service ports, or loading and unloading capability independent from the port's infrastructure. And at this moment at the Moses, we are dealing with specific technical and other specifications. So we would like to have a reduced ballasting and deballasting operations. We are also having the robotic container handling system, which will be mounted on the feeder vessel. It will be autonomous operated, and there will be an intelligent operation support system that provides situation awareness to the remote operator. So there will be a remote operator somewhere. So dynamic, for example, there will be a dynamic task allocation to the operations at the shore control station. Then, as I mentioned, we have the Moses innovation with the matchmaking platform. This will be a horizontal collaborative and collaboration logistics platform, which allows shippers to submit their transport needs, so the demand. And on the other hand side, we will have the transport operation in shipping lines. We will be able to advertise their scheduled prices for the short sea shipping routes supply. And this will be coupled, and this will be focusing, as we understand, to our innovative feeder vessel. So there will be an order aggregation at container level according to capacity, availability, user-defined criteria, legal and practical constraints in order to have a nice way to balance things. Now, about the innovative feeder vessel, we are looking on safety issues. We are looking on the environment, and of course, at efficiency aspects. So we will have the whole portfolio there for this innovation. The same happens with the robotic container handling system. We want, for example, to minimize risk in cargo handling and to increase the efficiency in various aspects, like for example, enable low container services to small ports that have limited or no loading and offloading infrastructure, or impact on the receiving port logistic infrastructure and port control organization. The matchmaking platform focuses mainly on the environment and efficiency. The environment in the sense that the shipper might be informed about transport services with low environmental footprint and is able to select them. leading to the reduction of the total emissions for the cargo transportation, and with efficiency, for example, single communication channel between shipper and carriers. Everything, though, will be more or less coupled and focused on our own vessel or our own feeder vessel. Now, we will have pilots for the tugboats, for the cargo container handling system, for the vessel in terms of the model testing, and for we will have some business cases. Here we have two of them: the Western Med Spain business case. Here we have started to, let's say, to identify specific features. 3 weekly services per year, per week. This is between the Valencia port, Sagunto port, and Gandia port. And you can see about the vessel of the size of the vessel that we are talking about. And a second business case comes from Eastern Mediterranean on the Greek archipelagos, where you can see a route or at various ports at the Greek archipelagos. Piraeus, the port of Piraeus is a partner of our project, as well as the port of Mykonos. And here you can see that we are talking about 2 weekly services in each port, and the ship is a little bit smaller, so one fits all doesn't apply in our cases. We will be, let's say, designing a class, a family of vessels. Finally, we would like to focus on this, sustainability approach. We are looking on safety. We want to be environmental friendly. We want to be efficient in order to reach cost efficiency. And the problem addressed by Moses, we do not think that has an obvious solution. The expected benefits will strengthen, of course, the presence of social shipping within the EU supply chain. Thank you very much. I tried to go as fast as possible. You can see here where are the various contact details of the project, our websites and social media details. And thank you very much for inviting us to this Connecting EU Insights 2021, the spring edition, in order to present, to draft and to schedule this session and draft the specific presentation. Thank you very much. I guess that we have overpassed our time for 3 minutes. So hopefully we would like to thank everybody. I would like to thank all the panelists for their interesting presentations and the discussions and the replies to the various questions. I will go through the last questions, and I will try to reply to them as I see them on the Q&A and on the chat. Thank you, Mercedes. Thank you, Sifis. Thank you, Ornalf. Thank you, Oderic. And of course, thank you, Alexio and the Circle Group for inviting us to this event. Thank you very much.